Hello, everyone, and welcome to Life Edge, because life just doesn't have to be that mediocre. I'm joined today by our co-host, Dr. Susan Nash, and we've got a great guest for you today, and you'll find out who that is in just a moment. Here we go.
This show is sponsored by Relate Corporation at www.relate.com, your training and video partner.
And we're back. And joining us as our guest of honor today, we've got Sashi Gunturu of Petrabytes. How are you doing, Sashi?
I'm good. Thanks for inviting me.
Thank you for coming on. And Sashi's doing all kinds of exciting things using cloud and distributed computing for analyzing oilfield data. Can you tell us a little bit about what led you to start Petrabytes, Sashi?
So most of the companies like in the oil field, they have data all over the place. And if you have all of these, so one of the biggest challenges for any oil company is the complexities of the subsurface. So they have different kinds of data, and data is increasing at a very rapid pace. And they have users in different locations. So they don't have enough workflows that are connected to provide a full interpretation of the subsurface. So by using the power of cloud, you can now build a scalable solution where you have the entire team all the way from seismic, geophysicists, geologists, geophysicists, everybody's integrating and collaborating in one single portal and building complex models at scale. And that's what cloud provides. And what Petrabyte is doing is to provide that one single collaborative platform where we can build these complex geological models at scale.
So, can you give an example?
So one of the examples is, for example, if you look at seismic, you have a much larger field. For example, if you see the UK basin, they have about 138 terabytes of data over that can quantify about 12,500 wells. Same thing with the distributed acoustic sensing data. The data is significantly huge. So typically it takes weeks for companies to analyze the data. So now with the power of cloud, you can scale these models, you can build it much faster, where you have teams in different locations all collaborating with one single portal. So it's essentially like having Google Docs for scientific computing. So where everybody is collaborating to build the model.
And if I understand correctly, you're using Microsoft Azure for your cloud solutions, right?
Yes, I mean, we got sponsorship from Microsoft on the Azure, and then that's how we built the solution. And now both with different cloud providers like AWS, they have a very compelling scalable models. Like AWS has Snowflake, which has a really good edge computing solution. Same thing with Azure. So I think eventually it will become like a hybrid cloud environment where anybody. So it becomes a multi-cloud scenario. So as of now, all our solutions run in Azure. It's a fully cloud-native platform.
When you say multi, how does that actually work? How would it work in multi-cloud?
Yeah, so typically what happens is, let us say you have an oil company that is using a lot of S3 storage from AWS. So they have all the data over there, and then you have another company that is using Microsoft Stack. So then what we could do is we can pull the data even from multiple sources. And if you are a truly cloud native approach, so you can use solutions and data, you can connect to different clouds and still have the same agility. So you don't have to really port your application to one or the other. You can still be independent and pull the data from different cloud providers, and also not only pull the data, but also access the services. So that is the advantage of having a multi-cloud approach. And if your applications, like for example, Skygridz or cloud native platform, it has everything built as microservices. So you can pull data, like seismic data from S3 storage. You can pull well data from an Azure cloud storage, and you can still have all these services running in a Google Cloud. So you can technically host your application, but pull the data from different sources and use the best of all the platforms. So,
Wow. And you said you're moving towards sort of hybrid cloud solutions. So does that mean your customers will be able to kind of integrate their on-premises stuff with your cloud services and all that?
yeah, so our platform is essentially cloud agnostic, but uh, both Microsoft and AWS, they have built their whole technology at scale. So the idea is, if our application is completely cloud native, so that it can host in either an AWS scenario or a Google Cloud or a Microsoft scenario. So it doesn't really matter which solution it is, but it depends on the vendor also, or the operating company, right? Like if a big oil company wants an AWS solution, then our solution can also be deployed, but also can talk to it. We need not be necessarily in an AWS, cloud. We can be independent. We can be on a Google Cloud and still talk to either vendors, either cloud provider.
That's great. Okay, so let's imagine that I have a company and I have data that's all mixed up in different forms. How would I get started?
Yeah, so there are different solutions. So for example, one is the variety of the data, and the other thing is structured versus unstructured. So for example, if you have data in documents, so there is no real structure for that. And the other thing is you have lots of data. So that is typically one of the, I would say, the primary challenge for all the oil companies. So what we could do is we provide a solution called Infogridz, which is taking all the unstructured data and providing a workflow and making it supervised learning. So initially you train the model to say read for certain specific columns in an unstructured data or specific area of information, and then you can train the model so that it can, next time when you get similar kind of unstructured data, you can read that. So that is on the unstructured data side. So where you take an unsupervised scenario where there is data all over the place and make it supervised. For the structured data, then you have APIs, like for example, OSDU, which is the newly formed consortium by all the operators. So they are providing an API for all the well logs and all of that. So in that case, you just have an API and like a REST API where you can pull the data of the structured data. So then you're combining both the unstructured data and the structured data together. And then when you're talking about scale, there are solutions like, even in the cloud, you can now deploy a cluster. You can do distributed computing even in the cloud directly itself. For example, previously, when you have large scale data like petabyte scale seismic or DAS data, people were using either high-end computers or a distributed networks like distributed computing like Hadoop and all these clusters. Now the same level of cluster computing is now provided in the cloud. Like AWS has a solution, same thing with Microsoft. So they have these automated ETL, like extraction, transformation, and loading. So you can automate the entire data ingestion of the subsurface data and make it ready for analysis. So all of that, you can use the power of cloud and also the solutions like one for unstructured and supervised learning, and the structured data with the API calls. So all of this will automate the entire data preparation process, which is the fundamental, the most difficult problem that the oil industry is facing right now. How do you get all the data together? So we are one of the companies that are trying to offer that solution of automating this entire data preparation layer.
Do you clean up the data too?
Yes. So we have this concept of business rules. So for example, if you take well data, right? So one of the typical things you have is the well header all right? Like, do you have the latitude and longitude locations? Do you have the API number? All those things. That is, you have what we call a business rule. So we track for missing data, those kind of things. So this happens when you're processing the data in the data processing layer. Let us say you have like 1,000,000 wells that you want to look at from multiple sources. We have that kind of solution. If you're looking at well logs, you have different kinds of business rules. For example, does it have a proper header? Does it have a proper unit? Does the mnemonics match? All of those things. So you have different business rules that you can embed based on the data type. For example, if you have looked at seismic data, does it have the right byte position? Are you pulling the right inline and crossline coordinates? So based on the data type, you can have different business rules. And what happens is in the process of processing, when I talk about automation of the ETL, you can now have these business rules that will apply across large scale of data. For example, if you have 1 petabyte of data, you can apply these business rules. You can define new business rules as well, and you can apply, and these will process on the cluster. So by the time it is all automated, it's you can move from on-prem to the cloud, all of that, and then you have the data that is fully cleaned and ready for analysis. So the cloud provides this whole automation, like ingestion from multiple sources, like from on-prem to the cloud, from different databases, proprietary databases, from unstructured data. All of this can be automated with the cloud tools that are providing. Of course, you still have to write the business logic. And what we also provide is ability to write your own business logic. For example, if you want to extract all data for porosities that is beyond a certain limit, you can write a new logic for it, and that can be deployed as a new business rule onto the cluster, which will now process against all the LAS files or seismic data or any of those. So the ability to create your own rules and processing this at scale on a distributed cluster, all in the cloud, will help you prepare the data. For companies like, say, for example, Shell, they would have tons of data. Same thing with all the seismic companies, right? So they would have lots of data. The cloud provides that automation capability.
So how would I am getting that, you know, the having this cloud-based service, it would make handling all of this unstructured data and putting it into usable form, you know, much more accessible. What are some of the ways that that could increase efficiency in a drilling operation?
Yeah. So, for example, if you look at, let us say you want to increase the rate of penetration, because ultimately you want to quantify. For a driller, they want to reach the target as quickly as possible and as safely as possible. So in that case, you can now build you can do 2 things. One is, what can the driller do? Like what the wellbore jewelry and all the weight on bit torque on those kind of things. That's what the driller can control. And if you have like a multiple set of variables, you can now build a machine learning algorithm to say what is my optimal rate of penetration that I can do based on all these mechanical properties like weight on bit, torque, all of that. So you can build a model based on that. Now, if you look at what's outside the formation, which is the pore pressure, the formation tops, all the stresses, all of that. So you can build another model for that, where you can say, given this mud weight, you can now build, you can now come up with an optimal trajectory collapse pressure. So what you can do is build 2 machine learning models that can quantify the mechanical properties as well as the formation properties, and you can train the model, and you can deploy this model for any new well that is being drilled. So this you can deploy in scale. Like, for example, I can build a model in the Houston office, and then I can update that model and deploy it for the wells that are being drilled in somewhere offshore Gulf of Mexico for all of these. So the idea of the cloud is not only to build models at scale, but also the ability to deploy across the fields at a rapid pace. So at the end of the day, you are optimizing the rate of penetration, because every day they drill, it's going to cost them money, right? So.
Well, and also I liked your point about the mud weight, because losing mud into the formation is expensive too.
Yeah. So the idea is, especially when you can process data in real time and also apply machine learning from a trained model, and then you can give results at the same time as quickly as possible, and now deploy these models at scale across all the fields. So that gives you, and that is only possible with the infrastructure. So you're using the power of cloud and also the edge computing to deploy these models at scale.
So can you use this for completions so that hydraulic fracturing is predictable and essentially safer?
Yeah, so we are working with a major operator on building a 3D geomechanical model. So the idea is to characterize all these fractures, you need to understand the propagation of the fracture and which stages are more efficient. So let us say you have like a 10-stage frac operation. The idea of having the geomechanical model will help you qualify whether those you need all the 10 stages or which stages are more effective during the hydraulic fracturing operation. So the ability to build the 3D models, especially on the geomechanics side, will help you identify the fracture efficiency. So that is something we are actively working on right now. So we are about to release a solution in the first quarter of next year in collaboration with this operator.
I have a question. Well, rig rate is going down. It's reducing. I mean, people are not drilling much for a number of reasons. So if you're a company and you are not drilling as much, I don't know if I'm signal here, but what should companies do when they're not drilling to efficiency or operational efficiency?
Yeah, so the idea of having like the 3D model is when you're not drilling, you can do a lot of things. Like you can build a lot of what if scenarios. So for example, let us say a company had a lot of problems drilling in a particular area with different trajectories. So now, for example, you can now build a geomechanical model. If you have a 3D geomechanical model, you can now have different kinds of what if scenarios of all the wellbore trajectories along, and then you can now quantify what could have been a better path to reach the target without any problems, like lost circulation and things like that. So when you're not drilling, modeling what if scenarios and also kind of creating more like in the realms of digital twin will help you better plan for the next job.
That's really interesting. So do you have any big plans for Petrabytes?
So the vision of Petrabytes is to be the gateway for the oil field. So the idea of using the cloud, not just for the sake of implementation, but the idea of having the cloud, it gives us several advantages in terms of building the models at scale. So with a fully web-based software, we would be like the Google Docs for scientific computing. Essentially, we want everybody in the asset team, all the way from driller, geomechanics specialists, geophysicists, management, data scientists, IT, everybody will connect to one single portal and they will be doing their respective jobs. And because it's all properly indexed with all the data ingestion and everything, we would now be able to provide that one unified collaborative solution where we would avoid any data duplication and master data governance. So you are improving the company's efficiency at several levels all at once with one single portal approach.
And Petrabytes has Skygridz. That's your GIS solution, right? For
So Skygridz is our cloud computing platform. So Petrabytes is the company. Skygridz is the
I
core
see.
product. Yeah, yeah. So that is
Okay.
what runs in Azure.
Oh, gotcha.
Yeah. So that's our product. Yeah.
At one point, I was thinking of this, and Sashi and I were talking about developing something that would be Zillow petroleum. We call it Pillow. So
Yeah.
it's that.
So just like when you buy real estate, right? When you buy a house, you look for what is the best location, is it a good school district, is it a quiet neighborhood, is it safe neighborhood? So you're looking at all these different parameters. So similarly, when people are buying acreage, they're looking at all the geological parameters. And what we build, what is called a suitability model. So the idea is it's a qualitative measurement of the area, like which area is more suitable for more exploration of the data of the region. So instead of, when you have so much vast area for exploration, you need to have some kind of a focus. So we would use these kind of suitability techniques and build a model so that now you can narrow down where to look for more in-depth analysis.
I like that. So one thing I'm excited about, we're having a workshop in November in Houston with Acreage, and we're going to have people who are talking about challenges reservoirs. But one thing is, we're going to have meetups to start implementing. So do a meetup and Petrabytes is involved. What would you talk about?
Yeah, so we have a solution where people can build workflows. So for the idea is, most of these complex reservoirs are very complex, and you cannot have one fit solution that can be applied across all the reservoirs. So we would like to give out our platform where people who have a lot of ideas and expertise in the regional areas can build their own workflows, so that the best workflows can be deployed, because ours is a cloud native platform. So they don't have to worry about how to get the data in. We'll have several test data sets, one from public data sets, like a couple of operators have donated to the field. So we could use that, and we could give out to the experts who can build workflows on top of it. So the idea is, you can speed up the area of innovation, and bring in the regional expertise, and people can build their own workflows. So that is one of the things we were thinking of as part of this meetups. And the idea is to collaborate with one of the best minds. So this is one way of engaging them, and we are also thinking of engaging the universities also, like University of Houston and University of Tulsa, to use our platform so that they can build new things, new workflows.
That's great.
So in that case, if you were working with the universities, would geological engineering students and geology students be able to like access your stuff just to learn it and that sort of thing?
Yeah. So there are two things, two goals, right? One is, we would want to get a lot of feedback to our platform, because it's a very complex things that like every field we are always learning. So that is one area where we want a lot of feedback. So more people use, the better it is. The second thing is, that will also help us, get the brightest minds to join our company, to work with the universities, and also it's a win-win situation for both the universities and for us, because the university students get to work with one of the best new technologies. So
Cool. And I also saw that you're using Skygridz to work with fiber optic data. Can you talk a little about that?
Yeah. So the fiber is like a continuous sensor where you're getting measurement every meter. So the kind of measurement you get is temperature. You can get acoustic, which is a sound, and also displacement, strain. Those kind of measurements you can get. So the idea is, let us say you have a fiber that is laid around a well. Now, just like any well log, you're getting measurement every meter. So you're essentially getting a temperature log every second, perhaps, and sometimes, usually they get like every 5 seconds or every 10 seconds. So that means using this variation of temperature and acoustic, you can now look for any well event. So for example, if there is a packer leak, if there is any influx of water breakthrough, those kind of events in the well. So why would they use fiber optics? So they would use fiber optics primarily for high dollar wells. Like if companies are investing like $50 million on a given well, so they want to know what's happening right away as soon as possible. And they want to continuously monitor for the life of the well. So life of the well could be 15 years, 20 years. So even though it's a high dollar investment, but there's a lot of money at stake. So companies want to monitor that. And with acoustic sensing now, it is being used for hydraulic fracturing, where they're monitoring the hydraulic fracturing events in real time. So combining the acoustic and the temperature measurements, now you can get more like a repeat seismic. So typically when people are doing 4D seismic, they're getting seismic every year or every 6 months or something like that. But now, once you have the fiber in the ground, you can get seismic, you can get the full 3D view of the well events and the reservoir events as and when needed. So they can get every month. So with that, you can now qualify the entire reservoir. And the beauty about what we are trying to do is the data is huge, and that's where the cloud computing comes into play, and also the edge computing, more importantly. So we process a lot of this data at the well site itself because it's generating several terabytes of data on a given day. So that's where you can use the power of edge and also the cloud. And the speed has been, the key thing is the speed of how quickly you can process this lots of data. So that's where the new technologies come into play. And I think it's a growing field because there are some companies in the fiber space that are using for monitoring smart cities. Like for example, fiber is there everywhere. They can look at how many cars are moving. There is one company that actually wrapped the fiber along University of Calgary, and they were looking at how many cars are passing through a given road. So there are a lot of applications of fiber optics, and Oilfield is now, even though it's been there for 10 years, I think the adaptation is growing very rapidly right now, with companies like Shell taking the lead in this fiber optic implementation.
Yeah, I mean, I suppose it makes sense to have the things like fiber optics and edge computing become more popular, since, as Susan was bringing up earlier, there are a lot of companies that are not drilling as much, or maybe there's fewer wells to be drilled, or different kinds of wells. So the ones that are there, I guess, all of these things that are going to make it more efficient and just stop them from lower the risk of failure.
Yes, and the fiber is also being used for transmission, like for example for pipeline monitoring, for hazardous material like H2S. Fiber is being used. So a lot of the companies that were funded, sponsored by oil companies, the companies that got funding, the fiber optic companies, they have use cases not just in oil and gas, but also in these pipelines and even railroads. They're monitoring railroads with fiber. So.
Well, that's interesting. And so if the fiber is there, then when people want to go back in and say refrac, you could use it for that too, right?
Yeah, so there are two ways of looking at the fiber implementation for hydraulic fracturing. So one is the modeling aspect, like you can model a geomechanical model and all of these things, like the frac models that you can do. The second thing is applying this model in conjunction with real-time monitoring of the frac. So where fiber comes into play is you're monitoring the frac in real time, and then you can adjust the model. So our bigger vision is eventually to combine the geomechanical models that would change as the wells are producing, and combining with the real-time monitoring of hydraulic fracturing with the fiber optics. So there are companies like Shell trying to do that. So we are in the process of building that model together, along with combining the geomechanical model with the real-time monitoring of fiber optics. And you can only do at scale when you have the infrastructure like the cloud and the edge computing to combine these, because both are massive scale models. Like a typical geomechanical model will be like 500 million cells, because you're looking at 50 square kilometers range. So it's significantly huge. And at the same time, you have the fiber optic data that is very big, like in terabyte scale. So you need the computing power to do both integration. And we are in the process of developing the solution right now.
Awesome.
Thank you.
Well, we are just about running out of time, but we have one more question that we always ask our guests here on Life Edge, and that is this. What, Sashi, is the one thing that you feel has given you an edge in life? What has brought you ahead?
I think perseverance, because it's very hard, especially to build a company in the oil field, in the software, because you are up against the big players, and that too, building a company in a scientific software company will take a lot of time. Like typically in a Silicon Valley space, 5 years you are probably exiting and starting a new company, whereas in 5 years in oil field is just the beginning. So I think the key thing why Petrabytes is still in existence is because of the perseverance.
That's a good one.
Great. Yeah.
Yeah.
Also.
Yeah. I mean, you have all the skill set, but at the same time, it takes a long time for you to implement a scientific software, especially in a oil industry that is very close knit, and you can't just deploy a technology, even though it's all there, but you can't deploy it in the oil field as easily, because the chances operators they don't take the chances of failure. Risk taking is much lesser compared to any other industry.
Oh yeah, because there's so much at stake.
Yeah.
Well, thank you for coming on, Sashi. It's going to be really interesting to see how this technology is going to change the oil and gas industry. And like as you said earlier, I guess the more people that use it, the more it's going to improve, and just the more stuff it's going to be able to do. And also, you were pointing this out about fiber in particular, but I think here it's true too, where as this technology improves, it's not only going to be improving for the oil and gas industry, but it'll help other things too with this technology for taking all this massive amount of unstructured and structured data and putting it to good use.
Well, thank you. Yeah.
I agree.
Yeah. All right. Well,
thank you, Sashi. It was really great to have you on. I apologize for my bad.
Well, thank you for your time, and thank you for inviting me.
Thank you, and thank you to everyone out there for tuning in to Life Edge, and we'll see you next time. Bye, everyone.
Thank you.